Okay, nice. Let's get started. So you're recorded. So the presentation is recorded, the audio is recorded. So everything you will say is there. Everything we will say too. So yeah, well, it's the beginning of the afternoon. Hopefully you will not sleep, and I'll make my best. We'll make our best to like keep it kind of fun. More people. Come on, join us.
We can get more tables.
Yeah, that's what I wanted to say. So it's a workshop. There's some content we will talk about, some stuff we will demo. There are a lot of exercises. We do it from like a 2-hour format to a 2 days format. So we can really kind of adapt also to your questions, anything you have. For the exercises, you need a laptop. I mean, it's better if you kind of try it out with us. We will give you the slides later. We will give you. They are on a Google Slides, public Google Slides, so you can go and do the exercise yourself. If you want to type, like you're there in the back and you don't have a table, we can get you a table to put your laptops on. Like, just if at some point it's too like annoying, just let us know. We can like move a table. Either this table there or there's a bunch of there.
We don't have our laptops with us.
Okay. They don't have their laptop. Cool. Okay. So, well, you're here, so I suppose you know why you're here. But we're gonna talk about Semgrep. We're gonna talk about many things about Semgrep. First thing, maybe, I don't know. I'm kind of going random. Who here knows about Semgrep? Who knows what Semgrep is? Wow, so many hands. Okay. How many of you have already used Semgrep? Okay, that's gonna be very scary. We're gonna go to the hard stuff maybe. That's like quicker than usual. Okay, so we'll give you more details and introduction about Semgrep, but it seems like many of you already know many things. The title says Funding Bugs, Scaling Your Security Program. We will do a wide overview of other things you can do with Semgrep, many ways you can use it, and so on. So a lot of content. Yeah, maybe a little bit about us. We are kind of inverting the content. Usually he starts, and then I introduce myself, so I'm kind of confused. You recognize me. I'm Claudio. I started, 20 years ago maybe as a security consultant. I used to live here, actually. I've been living here most of my life. And then I moved to Paris, where I've been living for 15 years. And that's where I started working in static analysis. So you might know other names like Fortify, Coverity. That's all places where I've been working. I started with some sales kind of thing. And then at Coverity, actually, I moved into the security research and some product engineering, actually. And now at Semgrep, I'm managing the security research team.
Yes. And so I'm Pieter. You can find me on Twitter or YouTube as 0xdcode. I started as a PhD student in Ghent University in Belgium, and I did my PhD at a company called Secure Code Warrior, and they have also a static analysis tool somewhat similar to Semgrep. And then after my PhD, I joined Semgrep, and I'm a senior security researcher, and Claudio is my manager. So I guess we can go over who are you, what's your role? Maybe we can start. I'm assuming most of you are security professionals in the security business. Who is in security? Maybe raise your hands. And so no developers. Are you offensive security? Who's pen tester? Okay. So who is using SOST regularly? Okay. Good. Do you want to, anything particular you'd like to learn today that we can maybe focus on? Have you written Semgrep rules before, the ones that are using Semgrep?
Not yet.
Okay. Okay, so we start from the very basics in this presentation, so we won't skip the easy parts. Part of our usual workshops is also bring your own code. So if you happen to have a recent memory of a bug that you found and you want a static analysis tool to find this at scale, later in the workshop, if you have time, we can send us the code and we can write a Semgrep rule together to find your bug. That's this slide. So send us your examples later. We start this presentation by looking at what is Semgrep, very briefly how it works. Then we'll start by customizing rules, why you want to customize rules for a SaaS tool, and then we'll do it ourselves. A little bit about remediation guidance, so fixing findings that you find with Semgrep. Semgrep has a feature which is called autofix to automatically transform the code into a compliant piece of code. If we have time, we can look at some more detailed analysis features. Maybe we'll demo them instead of making them into exercises to speed up, because it's only 2.5 hours left, I guess, today. And we'll do some bring your own code if any of you bring code examples.
Maybe before we move forward, do you need to leave at a certain, because it's kind of a Saturday afternoon, do you have to leave early? The official time is until 5. Is that okay? Can we go past 5? Should we stop earlier? Any special request?
Looks fine.
Okay, makes sense. So Semgrep, our website, is self-explanatory, I guess. It's a SaaS tool, but we say at ludicrous speed, so it's not as heavyweight as a traditional security tools that you might know, like Fortify. The name is based on semantic grep. Grep is a tool you're probably familiar with, but as you'll see today, it's quite a bit more powerful than just grepping for code. We're really a static analysis tool, not a text grepping tool. Some people, for some people, Semgrep makes them think it's a more simple tool than it really is. So how it works in the background, some of the architecture is there will be codes, actual code files. I think we have support for up to 30 different code languages now. So most recently Rust, Swift. We have all the traditional ones: Golang, Java, C#, JavaScript. You may.
And some weird thing. I mean, weird for me, like Solidity and Cairo, which are like blockchain, like smart contract languages, which I know nothing about. But we'll talk a little bit more about that because Semgrep is open source. We didn't add support for these languages. People using it that needed support, and they added support for like these languages.
Yes, so the first thing that happens with these code files is they need to be parsed, which we use the open source tree-sitter parsers for. And if there's support for a parser, we support that language, basically. Our rules are YAML format. As we'll see today, part of the rule definition is actual code. So your rule will look very similar to the target code language you're writing. And this will also be parsed into an abstract syntax tree. And then the analysis will basically compare the syntax tree from your code and from your pattern, from your rule, and try to match these.
I think there's a question.
Which languages did you support it first, and why did you choose this one?
I think the very first was Python. Semgrep started as a Hack Week project at the company before Semgrep was a thing.
Yeah.
R2C?
Yes.
Yeah. Okay.
So, yeah. I mean, now the story is, it's the semantic part. So, the engineer who invented Semgrep actually started working with the Linux kernel developers, to analyze patches, basically, patch diffs, to help them figure out if an API is changing, which places have to be changed to. Like, in which places the API must to be changed based on the semantics of this API. Then he went to work for Facebook at the time, and he tried to extend this concept to source code diffs to find vulnerabilities and to help developers fix their source code. And they were using PHP mostly, so he focused on PHP. And then we had a hack week when he joined us. The company was doing other things, so we were not, there was no Semgrep at that point. And he was like, well, I had this thing that could help developers like find vulnerabilities, but it's only for PHP. How can I make it like adapt to more languages? And so he added, like in a couple of weeks, he created Semgrep, so to say, based on his previous project to support, well, to have a more generic approach. So the first was probably, yes, Python, but yeah. I guess the main change was he used a different type of parser because the PHP one was one he made himself, I think. It was another project he made for Facebook. I think it was called PFFF, which stands for PHP front end something. And yeah, so that's how it came.
Yeah, and why Python? It was the theme of the Hack Week at the time, to do something with Python. So his project was, I'll add support for Python to my tool. So basically, some background, simple overview of what Semgrep does in its engine, in its background. Semgrep is open source, as we've mentioned already, and there are a bunch of people contributing. For example, someone that I recently remember is there was added support for Julia by the CTO of the Julia Corporation, and so it's easy to add new languages, add support for new features if you feel inclined to do so. It's mostly written in OCaml, so that might be a hurdle if you're not familiar with it. Also, the rules are open source, so we are in the security research team, and part of our job is maintaining these rules. So if you feel like adding support for new types of bugs or vulnerabilities in a certain language, we're the ones who are going to review your PR and maybe ask for improvements.
Yeah. So about the rules, there's this repo, which is public. Everybody can submit PRs. You can even, we'll show you a little bit from this online playground. You can create rules and publish them kind of directly. They go through our PR kind of field, the review, so to say. So this is all free, open source, and so on. It's licensed, I think, LGPL probably. There is, what we're talking about today is the open source Semgrep. There are other kind of commercial extensions. We're not gonna cover them, but it's basically an extension of what you see today.
Yeah, so our philosophy is it's free to use. You can download it, start using it for all kinds of purposes, and it's open source. You can add other things. You can run it locally, in a container, in CI/CD. We have a bunch of easy ways to run it. As you'll see, we have an official Docker container as well. And so, yeah, it can run anywhere, and we have also a generic mode, so we can even scan just JSON, YAML, any type of code that's, if you want to add support for more complex code, it's possible as well. And yeah, it's user-friendly. We recently were at a conference where some users and some lovers of Semgrep were discussing this. If they saw a customer not using any CI/CD security tools, they forced them to set it up in minutes to start using Semgrep in CI. So it's an easy thing to get started with out of the box. So if you want to install it, you can use brew or pip to install Semgrep. And to use it, basically you run Semgrep and then the -- config with a location for your rule file or folder, and then the next argument is just which folder or code file you want to scan, or you can use our Docker file as well. So now about customization of rules. The big reason for the motivation behind this is really every code base is different, every project, every customer, every company has their own way of doing things, and traditional static analysis tools don't have that context. So whenever they flag something that it's generically true, this might be a SQL injection or whatever, it can be very noisy because it's not specific to that code base. And one example that I have here is a static analysis tool might not have this context that in this code base they started using ensure logged in instead of ensure user. Something similar that I experienced when I first started at Semgrep, and I made a small contribution to the Semgrep tool. It was still YAML, and I was using still Python, and I was using a YAML parser, which is different from the one they were using at other places in the code base. And so they told me, this is not the YAML parser we're using, and then you could add a new check with Semgrep so that from now on only that YAML parser could be used. So you should really adapt whatever guidelines and whatever rules you want in your code base to be more specific, so that it's better, more concrete feedback for your developers. That's the motivation behind customizing your guidelines. And it's not only us who are saying this. You can look at some security maturity frameworks such as BSIM or OWASP-SAM, and they often include as something that is an indication of a very high maturity program, security program, use of tailored rules or customizing your static analysis tools is often mentioned as like the goal for a high maturity security in your organization. I also did some research myself during my PhD, which shows that tools like Sensei, what I was researching at the time, and Tricorder, a tool by Google, where they really put a lot of emphasis on customizing their rules, that this really has a big influence on the fix rate, so the interaction of users with the findings of your tool. If you compare this to other tools like CodeQL, who is claiming an industry-leading fix rate of 60%, you can see that this is really the ceiling of what you can expect by not customizing your rules. That means 40% of your findings are actually ignored by your developers and maybe not useful, which is a lot of noise for them.
And before going, I think the next slide is already.
So we also noticed this in our own data, where for the rules that our customers are writing themselves, we see 50% higher fix rate compared to the rules that our security research team are writing ourselves, which we put a lot of effort in, and still, if you customize it to your code base, it's going to be much more useful to your developers anyway.
Yeah, and kind of as an observation, if you heard about or used static analysis tools, they focus a lot on finding vulnerabilities. But to be very accurate, you need very complex analysis, which often means something very, very slow. It's not slow, it's just that it takes a lot of time to run the analysis. And there's actually many problems where if you have, like Peter was saying, if you have the right context, you don't need to know much about the source code. If you, for example, if your company or a certain team says for this set of for all of our web applications, for example, they're all written with the same language, they all use the same authorization framework, maybe you just need to make sure that the right annotation is used on all the web endpoints, for example, to make sure that, I don't know, a certain default role is enforced. Or for authentication, that all the API endpoints have certain annotation. There's properties that are very easy to encode, and for which it's very easy to write a rule, which will be, on the opposite, very hard to figure out in a kind of generic fashion. A little bit like, I don't know, cross-scripting is if you're using a framework like React, there are very specific ways to bypass the default encoding. So it's easier to enforce a check that says don't use this, don't disable these features, instead of doing the opposite and trying to like figure out all the possible ways like the cross scripting will appear. So that's kind of also the approach of Semgrep, where you can do a kind of a complex analysis, but you can also make it much faster and simple by just writing your own check.
So we start with a demo, and then afterwards we'll get you guys to do some exercises. Is this big enough for everyone? Can you read this? Okay, so
Just a
a bit larger,
one less.
like this.
Yeah.
Okay, so we are, as a very simple example, are going to look for all calls to the exec function, which is OS command execution, which you should not do. And I have a few examples here, so you can import the exec function and give it an alternative name, save function. So of course we want this to be marked as well. And Semgrep can use what we call test syntax. So this will indicate to Semgrep, I want the next line to be flagged. So when we write a rule, we can test whether or not this behavior is according to our tests. That's kind of like a unit test.
Yeah, that's only for test cases. So you don't need to add the annotation in real code. It's just for us to
So if I run
test our rule.
If I run it right now, Semgrep will not flag anything because my rule is nonsensical, and so my tests are failing because I was expecting this to be marked by my rule. That's basically what the test syntax means. So we want to flag all uses of exec, even if it's split over multiple lines, which is something that's already more difficult with the regular grep. We don't want some exec, which would maybe be marked by a bad regex if you use grep. We don't want to mark anything that's commented out because this is a comment, it's not actual code, and we don't want to find this print statement to an exec call, I guess. And in Semgrep you can simply use code. So I'm writing basically Python code, and if I write it like this, we will find all calls to exec with no arguments, which is the one on line 9 here. But of course we want to be more generic. We want to find any use of this command, and for this we have an operator called an ellipsis, which is 3 dots, and this is basically the rule. As you can see, all my tests now are passing, and I am finding all calls to exec as simple as this. So this is of course a very simple example, but as you will see later, we can do more complex things.
If
You
you
want to add something?
Yeah, and I'm just so this is an online playground that's hosted by ourselves. You can just run the same example, of course, locally. Of course, well, this runs in your browser, so there's nothing sent to us and so on. But you can start saving if you log in. At that point, of course, don't put your sensitive stuff in the test cases if you don't want it to store it basically on our servers.
So this is the simple mode, but as I talked to you before, we are using YAML files for our rules, and so this is actually just a YAML file in the background. We'll start with simple mode, but then later on we'll need the advanced mode and write some YAML for the examples, for the exercises. So you can now go to our, if you're on a laptop, go to our Slack channel, and there's a link to these slides, and on the next slide I have the first exercise, so you can go to go.semgrep.dev/slack and find the BSides Milano workshop channel, or you can immediately go to our slides, I guess, as well, which is this one. I'm going
And
to.
if you scan the QR code or take a picture for later, you just go, it links you to the same slides.
I'll go to the community Slack. I'm not sure if I posted the link already. BSides Milano. So either go to our Slack channel or to the slides directly. And then, so is everyone finding the slides?
Good.
Can I move to the next slide? So our first exercise is basically the same as the demo, but in Ruby. We're going to try and find all calls to exec in Ruby, which is basically testing if you paid attention to the demo. All right. So this was fairly easy. I'm assuming most of you found the solution.
We want to show some variation, how to capture one argument.
But that's the next exercise.
Okay.
So, as some of you already noticed, you don't want to look for exec calls to a hard-coded string, for example. That's an obvious case of what we call an effective false positive. This is a term introduced by Google in their tricorder paper, which is a very interesting paper if you're interested. And they define an effective false positive as a marking by a tool that your developer does not want to fix. Maybe because to them it's obviously not vulnerable, but it can also be it's too confusing or it takes too much time. It's a different perspective than a traditional false positive where you're looking at is this vulnerable or not. A traditional false positive, if something is marked by your tool and it turns out to be secure, that's a false positive. But here we're really looking at developer perspective. So how do you want to improve the rule that we just wrote? Well, we'll only try to find calls to exec with one argument, because when there's two arguments, the first one is the command, and the second and so on is the arguments, and this is secure from command injection. And the first argument should not be a string literal. So this is an improvement of the rule you just wrote as a second exercise. You can click this link for updated test syntax, or you can try to improve your rule yourself. There's some hints in the slides, so if you are stuck, you can click those links and read the docs.
Okay, did someone get the solution already? We do it?
Just gonna take a look, maybe my links are... Okay, so let's give it a go. I'll go to the advanced mode. So who has already found out how to find calls to exec with only one argument? I think I've not seen anyone yet. So we had the exec with ellipsis, with these three dots. This is any amount of arguments. But we have something which is called a meta variable.
Basically, the ellipsis mean everything. So if you use it in the arguments, it means as many things as I can find within the two parentheses. But you can use it in a function body. It means a number of statements. I don't care about what kind of statement or how many. So it's whatever I can find in this piece of kind of syntax, basically. So if you use it in the arguments, as Peter was saying, it means, well, I don't care about how many arguments or what kind of stuff is between these two parentheses. So it will catch one argument, but also 2, 3 callbacks defined within the parentheses, anything that can appear in the language.
But we also have what is called a meta variable, which you write with a $sign and any name that you give it. So I can do arc, for example, and this only represents one thing. In this case, one argument for your function. So if we run this, we'll find all calls to exec with only one argument. So we don't mark these with 2 arguments, and I guess there's no example without arguments. So has anyone found how to look for a hard-coded string?
Just codes.
Yes, so if we add around an ellipsis or around a meta variable quotes, then we look for a hard-coded string. In this case, we would find this one, for example.
So the other difference between the ellipsis and the meta variable is when you do the ellipsis, you say, I don't care about what it is. and I don't want to do anything with it. So you say you don't capture it. If you use a meta variable, you're also capturing the content of whatever you're using, just like with a regular variable in a programming language, so to say. So in this case with the ellipsis, it's I don't care. If you want to capture something, of course it's one argument.
You can also see what it caught in your message. So if I reuse this and run it in the messages, you'll see which are the arguments. So ls, cd in my code cases, which is sometimes handy for debugging a rule. So how can we exclude these? For this we have a pattern not. So we go for patterns clause and we add a pattern. So in this case we're looking for all calls to exec with one argument, which is like this, and then we exclude, which is with a pattern not. Hard-coded strings. This should be the rule.
You should put dots.
Yeah.
It's not $R, but
You need the ellipsis instead of dollar.
Ah, yeah. Okay, there we go. So any questions about this?
what if I want to specify, can I specify the name of an argument? Especially, so like the name of the variable is user input, for example.
Like this? Yes.
Yes.
So one way to do this, it's kind of an advanced feature already, but we have a pattern regex, and you could say, meta variable regex is what I'm looking for. So you can have additional analysis on top of a regex, on top of a meta variable. So in this case, you want this. I guess there can be multiple arguments if we want to capture this one. You want this one to be user input. You could have. This should be. And if it's anything, or this is just a normal regex. Yeah. So yes, I guess you could go based on the name of the variable in this case. But if we get to it, we also have a taint mode where you can try to actually figure out whether or not this is user input and not just based on the name of the variable. Any other questions? Okay, we can move on. We have another exercise. In this case, we are looking to enforce the order of two API calls. So we have Java code, and we have to verify a transaction before we make a transaction. And so an example of bad code is where we make the transaction first and then verify it. Also pay attention that this is the same T, the same transaction. If you verify transaction T1 and then make transaction T2, that's obviously also something that you want to flag. So you can go to this exercise. Again, don't forget the hints if you are stuck. I can on the computer if you want it. Saw your face.
I'm tempted to do something different. To pattern inside the function, and then do pattern this, pattern not the other.
But
I don't know if
the
it works.
syntax is on the function declarations. And I just wanted to show ellipsis can be used in multiple places, and
Okay, so let's
if
do
you
the,
want, you
no,
can
let's do
then-
the right one.
And at the end, you can even demo focus meta variable
Okay.
for something.
And maybe also the typed meta variable. If you want. Okay. So, as I was talking about with someone, there are many ways of writing rules for the same problem. And even in this case, I'm not sure I would do the same as the solution, and I will tell you. Well, I'll tell you now. I'm gonna write a specific solution because the annotations we have are in a specific place. So just to make sure that kind of the test cases matches right and kind of we don't get lost. But you could solve the same problem in many ways.
I'm sure I know how it works. I'm going to try before you start.
So let me start with the pattern, and let me take, well, these for example. Sometimes, especially if you're, for example, something we do also, you are looking at the code base, you find a vulnerability, you want to find the same thing in many other places. Sometimes the easy way is just literally copy-pasting the source code, the vulnerable source code, and make the rule out of the source code. So something you can do is just taking this piece here, copying. Oh, come on. Copying. Pasting. And then doing a few changes. So we are interested in any kind of function. So we don't really care about the name. So something I could do is just use an ellipsis here because I don't care about this function. This method name, or I could say method. And actually, let's say return value, I don't care either, so I can say return. I could use ellipsis, it's the same. And for now, let's say I don't care about the arguments here. And the other thing, well, this is a comment, don't care about that. In a method, you can have as many statements as possible, so let's do something like this, before or after. So here I'm saying, I want to match every method. I don't care about the class here. I want to match all the codes to make transaction, and I don't really care about this. Let's call it T, just for the sake of the exercise. But so this is going to match all functions, all methods, sorry, that make a transaction. So you see, you get pretty much everything. Now the next step will be to say, well, most of these are fine. For example, the first one is fine because before make, I verify the transaction. What I can do is say, well, I want to match this pattern, but not. Oops. Yep. But not.
Yes.
And again, verify transactions, and ellipsis to say there can be other stuff in between. So if I run this, hopefully all tests pass, because now the first one doesn't match anymore because I verified the transaction. These are bad because, well, here I don't verify, here I verify but after. So here I'm imposing this order of statements. Here I verify without making, so I don't care about it, and so on. So this is kind of a simple solution. There are other things you could do. Well, first, this is a little bit confusing maybe because it's matching a lot of lines. In some cases, maybe for a simple exercise like this, you don't really care. But another thing you could do is, I want to just like report it on the first line and be clear and say this is the method that is vulnerable.
Or to report it on the main transaction.
Let's do that later. Well, actually, you can. So if I change now, so if I change these matches, this rule ID might not like match anymore the right line. So maybe the test cases will kind of seem to fail. But something I could do is use this focus meta variable that says, once I match, actually I want to focus my finding on this piece. For example, I could say, let's focus on the method. If I do that, only this meta variable is going to be highlighted. So that's one possibility. I could probably do what you were suggesting, which is let's focus on make. I can already focus on the transaction, which is pretty much the same because finding is always where I make the transaction. Okay. So that's one way. So now I have this T, which is actually the actual transaction.
If you really want to do it on the make transaction function name of method name, you could turn it into a meta variable and then add some restrictions to the meta variable, like with the meta variable regex I demoed before, and then you have another meta variable to focus on.
Yeah, so
that's really what you want.
To focus on something, you have to capture it basically to say this is the thing. So what I could do is, let's call it make, because I want to capture it, but now it doesn't say anymore make transaction. So what I can do is, well, let's add another another condition that says, well, make transaction. Now, actually, I think it will be better to anchor it in general. So this will be kind of an alternative. It's a little bit annoying because you have to add this condition to like specify this name. It's a little bit more verbose, but that's the idea. Something I didn't talk about, I don't know if you have an exercise about it, but it's because many people say that Semgrep is grep. So, well, first, already something like this is basically impossible to do sanely with something so simple as grep. But there's something that, should I do something like this?
Yes.
With double parentheses. It's very weird.
You can do this type of transaction.
So what I can, so it's a little bit weird because I have this double parentheses. But what I can say is also say, I want to capture the argument, and I want to impose the type to the argument. So this is not this is called meta variable. Type the meta variable. I'm saying I'm gonna capture T, but I want T to be of Java type transaction. So if this was not transaction, but it was you could say something like this, and then you will capture only when this transaction is actually this type. So there's some type inference that goes on. Now it's a demo effect that probably will not work. Of course. Maybe it's just this. Yeah, no, it's matching. Yeah, don't need the parentheses.
We could edit that case where there's a different type, I guess. A test case.
Yes.
So if now here I say Oh, like this. Now this one doesn't match anymore. So you have all these, and it goes for these types. It also, the first example, the Python one, if you import like a function, pretty much the same. If you use the fully qualified name or like just the imported name, or alias or pass to variables, you get all this type of kind of semantic analysis.
Question?
Yes. What if I really want to match a transaction of T?
Like specifically?
Yes.
You can still do here. I'll tell you not now because it's a more advanced feature.
Okay.
So I'll show you during the next exercise.
Okay.
You can continue to the next exercise.
Everything's okay? Questions? We're going too fast, too slow? Good? Decent? Okay. Okay, well, that's another one. Same as the others. The goal here is to say, that's another, like the thing we were talking about before. For example, in this case, in the solution, maybe it's explained better. You might say, "Oh, I want my developers to inherit from a specific class because this class enforces, I don't know, CSRF protections." So the goal here is basically matching all the classes that don't inherit from my from my application controller, which implements some security feature.
All controllers. The exercise has other classes that are not controllers that don't have to inherit from application controller. It's a
Want another minute or just go through the solution? Let's go. Okay, do you want to help me write the solution? Which is a rhetorical question. Help me write the solution.
Should define the meta variable regex.
Okay, I should define a meta variable regex. To do what?
To get the action controller.
Okay, let me see. You will do immediately something like this?
No, because I need to I won't do that first.
Okay. So first thing, let's say we match controllers.
All controllers.
Okay, so let me take just an example here. So this, for example, matches all classes actually that inherit from something. But if a controller don't inherit from the base controller is a problem. So I actually need another condition. So I can do pattern either. And say this is interesting, this could also be interesting, because if I have a controller that don't inherit from the one that enforce CSRF protection, it's a problem. Now, I used controller here, but my convention somewhere says the class name must end with controller to be a controller. So what I want to do is say, well, I know that, for example, the controller name must end with controller. So this, for example, the last two here should probably go away. Or tell me I'm doing something wrong. Oh, yes. Okay, better. So the last two now are okay. So this is bad because it doesn't inherit from my class. This is bad because it doesn't inherit from the good class. And this is just the base class. And yes. To be honest, I will do something different than the solution there. I can say, well, I'm capturing this name here. This must be. Yes. So here's where sometimes it gets tricky, because now I have a condition on base, but in this case there is no base. So that's where sometimes it's a little bit tricky. The solution in this case is to just say very very simply I want to exclude cases where I'm inheriting from the controller. Just it's a little bit verbose, but it kinda works. And the last one will be, well, my base controller, my application controller is good. I don't really care about it, so I could add another condition. So,
in reality, you also can tell Semgrep not to scan or not to show certain findings. So you might not want to add this exception to your rule, but just tell Semgrep in your actual definition, don't scan this file or don't flag this issue. And I think it's a no Semgrep. I don't know if it works in the playground.
I probably will not work in the playground, but what you can do in the source code is saying no Semgrep. If you just do no Semgrep, it will ignore every type of rules, or you can do no Semgrep only for this rule, to be more specific. I don't think it works here. Yeah.
This is for when you run actually Semgrep in your command line or CI/CD.
Yeah. but that will be an option otherwise. Okay.
Any question? So there's two more parts that we can talk about. One is remediation guidance, and the other one is more analysis features, which has taint mode, which is more like a classic traditional static analysis tool. And in the interest of time, we can only go through one. So if you have a preference to see either, to do exercise about either, you can let me know. Or I can quickly demo remediation guidance and we can do some exercises on taint mode if that's all right with you. Okay? So remediation guidance, or actually automatically fixing the code for a developer, is something that's very beneficial. During my PhD, I did some research and I gave developers a programming exercise, and they all had the same time constraints and the same exercise to complete. And some of them received feedback from my tool with remediation guidance, and the others did not receive remediation guidance. During the assignment, they introduced the same amount of violations, the same amount of security problems. So these two graphs are not significantly statistically different. However, at the end of the assignment, the people who received remediation guidance, 79% of them ended their assignment free of violations. So compared to only 6% of those that did not receive remediation guidance. So this is a big indication that helping developers fix this, especially if there's a time constraint for their programming exercise, is of course very beneficial. Semgrep, in our data, we also noticed this with the rules that we provide autofix. We see a 50% higher fix rate compared to rules without an autofix. If you add an autofix to your rule, this can show up in a CI/CD, so in your PR. It can create comments with suggestions. It also works in the VS Code extension or in the command line interface. I don't have a screenshot of that apparently. In the VS Code extension, it kind of looks like a linter where you can apply a fix and it changes whatever the rule defined. So I have a demo on writing an autofix. I'll go to the advanced mode. So in this case, we're going to look for cookies where we have forgotten the HTTP only equals true flag. So my pattern will be to look for this auth cookie helper with whatever arguments, as long as it is not HTTP only equals true. This. So if I want to autofix this, I actually need to rewrite whatever were the original arguments. To do this, I can use what we call a ellipsis meta variable, which works like this. It's basically an ellipsis, but you store whatever is captured in a meta variable. And then I can reuse this in my fix. I can go, I'll just copy this. And I can add something to it, like that. And if I now go into the autofix, you can see that this line, this finding on line 9, would be replaced with secret equals test and HTTP only equals true. I can apply this and the code is fixed. This is how it works in the playground. But if you have this rule in your CI/CD, it gives PR suggestions. You can bulk fix things with the command line interface and replace all of the instances of the finding. It's pretty powerful.
And don't think only about source code, because you can parse JSON, you can parse YAML. So if you have a file with data and you want to enforce a format, for example, or some kind of validate the format of the data, you can do that with Semgrep. And you can also say, well, all of my, I don't know, JSON objects have to have a certain key. Well, you can use an autofix to say, well, I want to match all the objects and add like these keys, for example.
We do this for our own rules. So Semgrep rules are YAML, and when we want to create our like published rules, we want to add some metadata about the severity or the CWE number, and we actually verify and can add some of that metadata with Semgrep autofixes. You were gonna say the same?
Yes, I was going to say the same. And same if you, I don't know, you're using a tool that outputs JSON and you want to do some complex checks on the output. Well, you could use JQ, for example, but maybe if it's too complex, maybe it's easier to just write a Semgrep rule and kind of do the same kind of matching, but in a more familiar way, I would say, because the JQ can be horrible sometimes. Yep.
Is the fix suggestion also included in the serif output?
I don't think so in the serif output.
Huh. I don't know. I guess we can try. We can try maybe later, just output a file and say.
And if not, you can submit a PR or file an issue on our open source project. So we have some exercises. A tip that I can give for doing some of these is we already demoed the focus meta variable. If you have a focus meta variable and do an autofix, you only rewrite whatever is focused. So in this example, if you want to rewrite the false, you can capture it in a meta variable, focus that meta variable, and then your fix is simply true, nothing else. I can open the solution to quickly demo, I guess. So in this case, we're looking for auth cookie helpers that have this flag defined, and we use a meta variable pattern to say we capture the ones that are false, so we can focus on it. And then what we flag is only this false instead of the entire line of code, which makes the fix as short as just replacing it with true. So if you're writing autofixes, this focus meta variable can be a very valuable tool. Semgrep has text-based autofix, but for Python and Java we have an AST-based autofix right now as well. So in this example here, say there's an HTTP only false flag present, but actually the default value is true. So it can be as the fix can actually just be remove this instead of replace it with true. If you would have this as a fix in text-based autofix, you'll run into problems. And you'll see that if we parse this code example to a syntax tree, in this case the before is secret equals test, then we have our HTTP only equals false, but the after ellipsis is actually empty. So if we replace this in our autofix, we have the autofix before and after. You can see that we have a comma too much, and this is actually invalid Python code. But with an AST-based autofix, this is fixed. So because we parse it into an abstract syntax tree first, we have an object instantiation with a name and some arguments, and these arguments in the fix pattern are before and after. If we then replace the actual values of these meta variables with an empty string in case of the after meta variable, then this tree is then printed to code. This is actually having the correct amount of commas, and so AST-based autofix will be more accurate, and we'll hope to roll it out for future languages. But you'll notice in Python and JavaScript, you'll have less frequently incorrect fixes.
Basically, instead of replacing the text, we we parse the source code and reprint it. So if we remove a node from the AST, it's not there. So when we reprint it, there is no comma because there's just one argument. So it's just a lot more work for us to implement all the printers for the languages, basically.
So now we'll move on to the more analysis features, and in particular we'll talk about our data flow capabilities. So quickly, some data flow analysis terminology. Typically, when you look for a vulnerability in a traditional SAST way, you'll look for user input, maybe URL parameters, cookies, some things that can be changed by a user, a malicious user particularly, and you'll look through the data flow and the control flow of the program and see if it reaches a vulnerable place in the code. And that's a bug, a vulnerability in typical status analysis tools. This source of where the user input reaches, that is what we call the taint source, and where the vulnerable place in the code is, so where this user input should not reach, is what we call the taint sink. This can be an unparameterized SQL query, an exec like we've seen in the first exercises, maybe just printing to plain HTML code. There's a bunch of vulnerable ways. You're probably more familiar with them than I am. So in this example, we have a taint source where user input enters. This is actually the string args because it's a command line parameter, I guess. And the sink in this case is the exec. So those are some examples of source and sink. We have some more for inspiration if you want to write your own rules. So finding a vulnerability in many cases is actually just basic data flow problems, I guess. Yes. And there's a few more terminology that we want to introduce, which is a propagator. This is where input propagates from one object to another. So in this example, we have the args. They are stored in user command, the first arg, and then it's appended to some string here. And this one is used, so we call this a propagator. And there's also a sanitizer, something that clears taint. From that point on, you can consider it safe to use. So we have a variable, a method, for example, here, filter file path, which then would render this sanitized path safe to use. And so if you want to write rules that do this data flow analysis, we have a few different modes. So far, we've actually been writing rules in what we call search mode, which is, as you've seen, semantic aware. It uses some symbolic propagation. We have autofix, but we also have a few other modes. And in particular, we'll be talking about taint mode, where we can do some data flow analysis. We can define sources, sinks, propagators, sanitizers, and we have some more advanced features like taint labels, which maybe we'll be able to demo as well.
So there are two things we are not going to talk about, just because it's, well, we can talk but not show too much because it's we will need too much time basically. Kind of to go back again, we are talking about Semgrep open source. There's one piece of the philosophy was it must be fast. So one choice that was made was to make the analysis single file. So all the rules you see will run on one file at a time, and even when we talk about data flow, Semgrep will not follow data flow between multiple files. So if you define a class in a file and use it somewhere else, Semgrep open source will not understand that. I'm not gonna go into I'm not gonna do the sales pitch. There's a product that does that extends Semgrep. But the two items there at the bottom are in the open source Semgrep and kinda work very well in many cases. So one is extract mode, where basically it's a very silly example, but it's the most common and simple to explain. If you take a piece of HTML, you probably have JavaScript embedded in HTML. So what you will like to find problems in JavaScript even if it's been embedded somewhere else. So with extract mode, you can say, use this rule to extract this language from this other language. So it could be, take all the script tags extract the content of the script text and maybe glue it together because it's just one big script executed in the DOM. But you can do other things. If you know what a Jupyter notebook is, you can have Python inside the Jupyter notebook within a JSON kind of blob. So you can use extract mode to extract JSON and basically concat back all the Python that's embedded in the notebook, and then run the Python rules on this code. So that's one way to kind of break this simplification of running rules on something very simple. And the other thing, it's an experiment, so it might go away in the future or just require the community to kind of keep it alive. It's called join mode. It means you can have multiple rules. One, for example, that parses, that's a case I saw recently. You have a rule, like a property file in Java, where you say some key equals some value. And maybe you're saying these are algorithms, like crypto hashing algorithms, and this is the actual name of the algorithm. So you say my algorithm 1 is MD5, algorithm 2 is SHA-1, and so on. And then you have a Java file that instantiates the algorithm. So you have a typical message digest something, blah, blah, blah. But you take the name of the algorithm from the property file. So these are two different things that you cannot do if you look at just one file. With the join mode rule, you can say, oh, I want to match in a meta variable my key and values from the property file, and it runs this rule. Then I have a rule that says, oh, I have a class that instantiates something, and the name is captured again in a meta variable. And then with join mode, you say, like in SQL, I want to join the meta variables. I want based on their value. So basically, you are able to say, well, my problem happens only if these two meta variables, so the key of the property file is the same, and if the value of the property is MD5, for example, if you're looking for insecure hash. So a way of kind of running multiple rules on different files and meshing them together. Yes?
This is my German code that would be useful also for flag. For finding the flag, I have a file with the configuration of true flag and analyze what type of result code I can obtain from a particular configuration of flags.
I think
have the same code for different type of customer, only customized by true flag.
Okay, yes.
Use the join mode to have the final version of the customer.
I think so. Because as long as you can match kind of these things and then say, oh, I want this variable have the same value of another one, it's basically. But you can it's called join mode because it's like SQL join, basically. You have two tables, so two set of meta variables, and you match them based on their value.
Okay, so right now we're gonna demo and maybe do some exercises about taint mode, which is the second mode for data flow analysis. I have made an example here with very specifically using the terminology of source and sink. So we're going to look for all cases where input is received from this source function and reused in a sink function. We'll see that some propagators are hard-coded, such as string concatenation, but some others are not. And we'll add some sanitizing functionality as well. So to write a taint mode rule, you have to specify mode taint, and then you need at least two keys, which is the sources and the sinks. These are all the same patterns as we've been using before. So for a source, you can't just write the same. If you would be looking for this function call in a regular rule, you would just write source. You could specify the amount of arguments as well, like before. In this case, it's always going to be empty. And for a sink, we can do the same. So in this case, we should be trying to capture all cases where we flow from source to sink. You see that this one is correct, this one is correct. So when we concatenate, this is a hard-coded propagator, and when a function, its return value is stored, we also consider this a hard-coded propagator. Why is this PL? Oh, this is a, okay. So this is a sanitizer, and we don't expect this one to match. So in order to code that, we add a pattern sanitizers, and our pattern in this case sanitize. I think it's as simple as this. Yes. And then for the last one, you can see that we defined a specific data structure ourselves that Semgrep is not aware of. And because you do an add function which does not return an object that is then used, but it's modifying this object, so it's not clear that this is now a tainted object, we have to code a propagator ourselves. And a propagator looks like this. You have a pattern again. But we need to define from which object or variable it propagates to which other one. So we can use meta variables to code this. So in this case, we wanted to flow from the S to the D. So to add from. I'll use these meta variable names because that makes it very obvious. And then we code from and to. That should be it, I think. Yep. As you can see, we now have a finding because we told Semgrep if we use this add function. And again, we can use type meta variables to define to only do this on certain data structures or exclude it from certain other data structures. But this is the basics of a taint mode rule.
So,
you want to demo?
No, just a. If you, for example, if you used Fortify, some of you in the past, so.
I need to look for the right tab. Sorry.
There's the last one, no?
No, this is
there. At line 14, you see Semgrep is assuming that every function will return the tainted data. So every function by default propagates the taint. That's also the reason why line 29, retrieve, returns the taint. It's a very, you could say it's very false positive prone because you're assuming that everything might kind of be a pass-through. So there's an option at this same level, the top level there, you can add options for the analysis.
Do you know its name by heart?
Don't remember the exact key, but you can also change this behavior to the opposite and say don't assume that functions will return. I think it's assume something, but anyway.
Assume. I don't think it's auto-completing.
It taints the return value, but it doesn't taint the argument.
There's an exercise about that?
It taints the return value, but not the argument.
So, for example,
that's a default behavior.
It sanitizes the input and returns it as the output of the function in the return value. But then, if the previous argument is used, then that is.
Okay. So your question is. So this is your question, right? You would expect S1 to not be flagged, but S to be flagged. Oh, this is. Oh no, sorry. The sanitize. I'm wrong. So your question is for this, if you.
It should be flagged as it is, but S1.
Right? Yeah. I'm sorry. I looked at the wrong test case, but that's the default behavior. So the original here, it's still the tainted value, right? It's the return value that's the sanitized, untainted one.
Now, you can also say, line 22, you could say, I want to sanitize S. I want to sanitize the argument, not the
Yes.
return value. So that, I don't remember if there's an exercise about this, so if you are spoiling another exercise, or...
I don't know by heart either. I don't think that's an easy one to do by heart. I think I would do focus metaverse.
Yes, yeah, me too.
I think that way you sanitize the original one.
So you're saying I capture these, but then what this pattern is matching now is something specific.
It's also, we need to add by side effects, I think. There's an by side effect true, something like that.
Yes.
Okay, it's not required.
Yes.
The side effects.
Yeah. You can use kind of these kind of type of pattern. You can use it, say, for sync, for example. If the sync is just one specific argument, for example.
Yeah, so
Or for the source, if the source is not the return value, but an argument there. Basically, everywhere you can say my source or something else is a text range, and you can match whatever, and whatever you match becomes your kind of source, even if it's not the traditional kind of return value. Or
is that what you're talking about? So you could also specify more granularly only the second argument should be tainted. No, I guess I need to remove this first.
yeah, so you can say I want to match my sync is a function that takes two arguments, but the sync is second one. Something like that.
This doesn't need the by-side effects.
No.
By-side effects.
No.
This is just telling Semgrep the sync is not actually this method, but it's specifically the second argument of this method.
Right, thanks.
Alright, so if there's no questions, we can do an exercise about this. We still have half an hour. This exercise is in Java, and specifically we will consider a source of input, this request parameter. So do not pass any request parameters into a runtime.exec call. Okay, so I think most people have found the solution, so maybe you can help me solve what's going on.
We should define the source and the sink.
Yes. So, what do you consider the source in this case?
The rec, the HTTP serverless rec, serverless.
You use how do you use a type meta variable?
HTTP servlet requests.
Yes, you can specify the full path. It's
Rec.
yes.
I just have one question.
Yes. What's your question?
Why is it so important to have a name variable here, $rec, and not
Good question. So I think this is just a way of how it was initially developed. So it started with meta variables, and we made it into typed meta variables. Actually, I think maybe in the future it's apparently quite of a maintenance burden to do this in every language, because syntax is different in every language. And so what recently has been released, I think last week, we released meta variable type, so that you can just have a meta variable and then specify its type similar to the regex or other meta variable definitions, which I think will be more generic and easier to understand, because having this syntax change based on each language is kind of confusing.
Okay.
So yes, this is a good source. you could consider HTTP request as a source of user input. And what would you define as the sink? Anyone else? Yes, exec, but as you noticed, there's a test case for a different exec, so we have a runtime or .exec. So another way to go about it is what you could have considered getParam as a source of user input, because a parameter is more tainted. There could be parts of the request that are actually safe to use, and this would be more specific. In that case, we can show you, I guess. GetParam. This would have been passing. So in the current solution, there is one test case that is failing, because it's the getSafeParam, but we can also define a sanitizer to get to the solution, which is, I think, what you proposed.
Yes.
Sanitize. Is it the Z? Yes. That's an alternative solution. All right. So right now we've considered user input as a taint source, but it's not necessarily user input that you want to track. You can use a taint source for any object which data flow you want to track, and we actually have a nice demo for that. So I have an example here where we have a YAML parser in Python, and you can define it as an unsafe. You can declare it and create an unsafe parser, or there are ways to create a safe parser. Actually, the default one is safe, is secure as well, but you can then load data with this parser. And actually what you want to be flagging with your rule is the combination of user input being parsed with an unsafe parser. So let's gradually build this rule. What we've done so far is, as a source of taint, we've considered user input. So in this case, can you open to make sure that I do the right thing? We could go for user input from the path, and as a sink, we can do the load. I think this should, it's not flagging yet. What is the source again? Self.path, that's what I have. Oh yeah, YAML.load. So whatever we've named our YAML parser.load is, so the first step to creating a rule like this is you want to look for user inputs, and it should be loaded, parsed by this YAML parser. In this case, we are checking user inputs, but it's not necessarily the case to do that for a taint source, and we can label actually taint sources. So in this case, I'll give it the label user input. And in that case, if you are using labels, you can define in your sinks which taint labels should reach this sink. Requires, yes. So this should still be the same behavior. We're now basically telling Semgrep, well, this self.path is a source of taint, and this taint specifically we call user input, and if this taint reaches this YAML.load, that's a marking that you should flag. So it's still behaving the same as without labels, but we can add other sources of taint. And in this case, actually, we were looking for an unsafe creation of a parser. So let's look for this, right? any parsers that add the optional argument type unsafe, like this. And we'll give it a name as well. So label. So this is the type unsafe parser. And what we actually want to flag are all things where both of these come together. So you've had an object created as an unsafe YAML parser, and it's parsing user input. And you can define this as such.
You use and.
You can use any logical operator and say and or not, basically, and combine these different conditions.
So this shows that, of course, a YAML parser creation is not user input, but you can kind of abuse or taint mode to track the data flow of other objects and how they flow together. Not in this demo, but you can have propagators that transform a label from one type to another. You can have sanitizers that only clear certain labels. So with taint labels, you can do very advanced stuff. Should we do an exercise on this in the last 15 minutes, or do we have other stuff to talk about? Who's still up for doing an exercise about this, or who wants to know some more stuff that we can talk about? Raise your hand if you want to do an exercise. Okay, that's clear.
I can talk through another kind of similar situation. It was a question I saw in the community recently, which was kind of the same. It was the first time I used the taint label. Someone who were saying, I want to flag cases where someone is using a logger to write something in a log, and where the data that's been written is some kind of sensitive data, like exceptions, for example. So I was like, okay, this is very hard. You could do it with like patterns. Even here, you could try to match like these specific pieces of syntax and say like, create a very complex pattern to match these conditions. In that cases, I was like, okay, it's much easier to say I have multiple conditions and I want them to be true in the same place, which is where the data is logged. So basically, you can use taint label to say this thing creates a logger, this other thing creates an exception, and the bad situation is when the logger is a function of the logger is called with the sensitive data. So you could have the same for cryptography, for example. If you are like, I don't know, using the wrong algorithm with some sensitive data, or probably you could use it for like to make sure that things that looks like passwords or tokens go through cryptographic APIs, for example. So every time you have multiple conditions, probably you can do something with taint labels.
Another example of a rule that I recently wrote was a Java XML parsing. I had a taint label for the parser, a taint label for the user input, and then I had labels for the secure configuration. So a few actions that can be called on that parser, like disable entity parameters, disable general parameters. And so the end condition of my sync was requires the parser to be created, requires user input to be there, and not this security feature or this security feature to be enabled. So you can do pretty complex conditions this way. Something else that we can talk about is we are testing a new simplified rule syntax. So right now you've been writing rules with patterns, pattern either, pattern inside. For me, when I first wrote my rule, I kept forgetting if it's pattern inside or inside pattern. We're testing a new simplified rule syntax where we have all, any, inside, regex, and a rule. Let me try and make this bigger. Will then look like this and be more readable. So you can basically read this out loud as match all of these where this focus or match any of these patterns where this meta variable is this regex. So it should be more readable after a few weeks. So if your rule is written a while ago, it can be hard to parse sometimes, and can be easier to remember the keywords, because it's no longer pattern inside and pattern regex, but it's simplified. So feel free to try it out. We don't have time to do it right now, but it should simplify some things, but it's still silently released. I don't think we have docs on it yet. Some bring your own code is not going to happen today. We have a few examples of Semgrep use cases. So you can use Semgrep to find calls to certain functions. Something that's commonly done is audit type rules, where you'll try to find specific calls to specific functions that an auditor wants to manually inspect. Or another type of rules that is actually written by an Italian, maybe you want to explain, but this person is using Gydra to decompile binary code and then uses specific Semgrep rules to find vulnerabilities in the decompiled code, which is another use case for Semgrep. And if you want to do some more exercises like this, I have links here to a full day workshop that we did a few weeks ago with many more exercises on taint labels and remediation guidance as well. Or you can look at my or our colleague Enno's YouTube channel, where we do some live rule writing, show off some more advanced features. I have a video on taint, on the new syntax as well, if you want to see a rule being written. And yeah, that's basically it. Thank you for attending. If you have any questions, please send us. Don't hesitate to contact us on LinkedIn or Twitter or wherever. The community Slack, where we always respond there, and our colleagues. So if you're writing rules and you can't figure it out, please send your playground link, and we will happily help you or the community to figure it out.
Very cool.
Do you have?